Hi everyone. A big problem now that involves multiple steps and the introduction of what we call a 2-to-1 ratio. Here's the question. Determine the pH of the solution produced when 2.00 grams of strontium hydroxide is dissolved in 850 milliliters of water. Our first step is to take the mass and convert it into moles. The moles is the mass over the molar mass. Here we have 2.00 grams, that's our mass. Over the molar mass. We have the chemical strontium hydroxide. We need to find its molar mass. It happens to be 121.64 grams per mole. I do this operation, 2 grams divided by the molar mass, 121.64. That's equal to 0.0164496 moles. After we have the moles, we can convert that into a concentration by doing C equals N over V. We have our number of moles here. It's our answer, which is equal to our answer, which we have right there. Still just keeping it on my calculator screen, divided by the volume converted into liters. We have 850 milliliters. That's 0.850 liters. This answer is still on my calculator screen. I'm going to divide by 0.85, which is equal to 0.019343482 moles per liter. From here we have a leap. And this is the place where this 2-to-1 ratio comes in. We're dissolving strontium hydroxide in water. It's an ionic compound dissolved in water. We have the strontium hydroxide dissociating into strontium ions and 2 hydroxide ions. We have the concentration of the SrOH2, the strontium hydroxide. Here it is, 0.019. But what we need to continue our work is the concentration of the hydroxide ions. And they are in a 2-to-1 ratio with our original compound. To take the concentration of the compound here and to convert it into the concentration of the hydroxide ions, we need to multiply it by 2. That's not an amazing mathematical step. However, it's a crucial one to arrive at the answer. So we need to take this answer and say that the concentration of these hydroxide ions is our answer down here times our 2-to-1 ratio. That answer is still on my screen, and I'm going to multiply it by 2. And I have 0.0386869, etc. moles per liter. The concentration of the hydroxide ions. We can't lose track of where we're trying to go in the end, which is to determine the pH. We have the hydroxide ions. At this point, we can do some math to turn them into the pOH. The pOH is the negative log of the hydroxide ion concentration, which here is the negative log, once more, of our answer, 0.0386, etc. This number that is still here on my calculator screen. So I'm going to do the negative log of that answer. I have 1.41243, etc. as the pOH. However, in the end, I'm being asked for the pH. So we have one more step to go, and it's to convert this pOH into a pH. And the pH is equal to 14 subtract the pOH. So we have our 14, and we're going to subtract our answer here, 1.41. 14 subtract that answer is 12.587564665. We arrived at the raw answer, 12.587. We need to go back to the values in the question and think about the significant digits. We have two numbers in the question. We have the mass at 2.00 grams, and we have the volume, 850 milliliters. Each of those numbers have three significant digits. So we want our final answer to likewise have three significant digits. It's the pH, only the decimal places are significant, so we want 3, which is 12.588. Finally, the pH does not have units, so we made it to our answer. It's worth reflecting at the end just to think, does this even make sense? Is it reasonable to think that a certain amount of strontium hydroxide could have a pH up around 12.5? The answer, of course, is yes. Strontium hydroxide, because it has hydroxide ions in it, is a strong base. Any kind of ionic compound that has hydroxide in it is going to be classified as a strong base, which means it would have to have a very high pH. Here at 12.588, that fits the bill. So we've run through the math and had a moment of reflection at the end, and we've come to the conclusion that our answer does make sense. This is a very complicated style of question because we have multiple steps, multiple different kinds of formulas going on. However, the crucial moment is that there is a 2-to-1 ratio between the hydroxide ions and the strontium hydroxide. And that's a very significant move to arrive at the correct answer. And I hope that helps.